Hello, my name is Louis Talley with InSource Solutions, and today I'd like to spend a little bit of time talking about some VMware troubleshooting basics. There are a number of different metrics that we can look at with regards to how the hypervisor is performing. So let's start with memory. ESXi is very efficient at managing its memory, so it uses a number of different techniques such as transparent page sharing, host swapping, compression, as well as ballooning to better manage memory. You can actually overcommit your memory, meaning you can commit more memory to your guest operating systems than you actually have, because ESXi does a great job of managing this memory. It comes at a price because performance can suffer in the guest. So one of the things that we want to look out for is ballooning. Not that the others aren't important, but I just have noticed more and more instances of customer applications where this is becoming a problem. So ballooning is a memory management technique where the hypervisor will force the virtual machine to inflate or deflate its page file inside of the virtual machine operating system. So what the guest operating system considers least valuable, this causes the VM to inflate its local balloon. So it's basically taking what would normally be transactions inside of RAM and writing them to a local file that likely resides on the data store where the VM is. So that can cause some pretty significant performance problems. So how do we actually visualize and diagnose memory ballooning? What you're looking at now represents a display from the vSphere client that allows you to visualize memory ballooning, among other things. So in the first picture over here on the left, you see the resource allocation tab of the virtual machine. And if you notice, under memory, for guest memory, there's an area dedicated to balloon. So we can see that this guest has ballooned some memory, and this is a bad thing. So there are other ways to visualize that. So this is a chart view here. So the nice thing about the chart view is I can look at the chart view for the entire host and see if there's any ballooning going on. As opposed to the graphic over here on the left, I have to go guest by guest. There's other ways to do that, but this is just a simple example. So in this case, this was something that I forced to happen, so I knew it was going to happen. But if I didn't have that knowledge, I could just come into the host and look at the memory and see, like we see here, that I've got ballooning. So let's talk a little bit about the CPU. So one of the biggest performance issues that I've come across is a metric called CPU ready. And this is basically the percentage of time that a virtual CPU or a CPU that is allocated to a guest operating system is ready to execute, but it's waiting for the hypervisor to schedule it to execute. So VMware recommends as a best practice to keep this below 5%. So how we do this is by right-sizing our guests. So oftentimes we find ourselves trying to overcommit our resources. So we have this big honking server and it has lots of firepower, and we think, okay, let's go in and just allocate as much resources as we can to it. So here's an example where I actually did that. So the graph over here represents some VMware system platform images running, and the area that's highlighted is actually the latency, the CPU ready, where the guest would be waiting for the hypervisor to say, I've got a physical resource to execute your instruction set on. So once I right size this, you can see that there's a significant reduction in this. So how this manifested itself was sluggish guest performance. So what I actually did was change the configuration, change the number of virtual CPUs in each guest from 4 to 2. So this is, like I said, a classic example of me saying, oh, we need 4, let's give it 4, or we need 8, let's give it 8. So what we need to try and strive for is to right size our guests. So when I made this change, guest performance greatly increased and the CPU ready decreased. So I'm able to take better advantage of the hypervisor and how efficient it is in scheduling execution across multiple processors. So the next thing we look at is disk. So we could spend a lot of time talking about disk. So it's important to try and understand where disk latency can come from. So there's a number of metrics that are published, and visually you can see here that will give us an indication of where the latency may be. So, is it latency in the storage? Is it latency on the network? Is it latency in between the driver and the host bus adapter? where does that latency come from? So there's a number of tools that we use. I developed a basic report card that measures all these metrics inside of Excel and looks at all the published best practices from VMware and other sources to be able to input some of this data in to help give us an indication of where a problem exists. Network. So the idea here is we don't want any packets to be dropped. So ideally we should never see packets dropped. Packets can be dropped for a variety of reasons. I've seen packets dropped by improper configuration of the guest operating system using a different type of virtual network adapter. So changing it to a more modern one worked better. It allowed the hypervisor to take better advantage of the frame buffers inside of the driver. Sometimes this is hard to visualize with the vSphere client because the data is aggregated. So I put together a little scenario here. This is just a command line interface to just show you a VM that is dropping 6% of its packets. So this just happens to be an ESX top display. All these metrics are kept and managed by the hypervisor. Like I said, it's a little difficult to see in the vSphere client because the data is aggregated, but here we can see here clearly there's a problem with one of my guest operating systems here. So this happens to be my domain controller, and again, this is something that I intentionally caused, so I know it's a problem here. So some helpful utilities. ESX plot allows you to graphically analyze and visualize the output that comes from ESX top. ESX top was the display that you saw on the previous screen. So it's a command line interface text-based tool. ESX plot as well as visual ESX top allow you to graphically analyze that. Sometimes it's hard to see from all the mountains of numbers that ESX top gives us. IO meter is something I found to be useful, and it allows us to test the performance of your storage. So I can create a file and transact against it with IO meter, and it tells me a variety of benchmark statistics that tell me how well that storage is performing. Wireshark is also helpful in analyzing network traffic. So in the previous example where we see that there are packets being dropped, we could understand a little bit more about that traffic. So is that traffic that's destined to the VMWare historian, so you're losing data to your VMWare historian? Wireshark could be useful in analyzing something like that. So we've seen a number of different very basic ways that we could troubleshoot. Thank you for your time, and if you have any questions, please give us a call.